Alright, so solving quadratics by completing the square. When we solve a quadratic by completing the square, we first want the quadratic to be in the standard form. And we're looking to get it into the completed square form, which later we'll talk about as vertex form. So let's streamline it, and I'll call it vertex form. We'll do that by completing the square. Now, before we talk about step-by-step how do we do it, let's look real quick at why it works the way that it does. So you see the bulk here, the thing that has x minus h squared. That's our goal. We're trying to condense the standard form into this squared form. So why does what we are about to do work? So let's look at things that are in that squared form. So something like x minus 3 squared. Well, if I multiply that out, x minus 3 times x minus 3, I'm going to end up with x squared minus 3x plus 3 times 3 gives me 9. And so if you look, combining my like terms, these two right here, I end up with x squared minus 6x plus 9. Let's do one more, see if we can find the pattern. So let's say that I have x plus 5 squared, right? Kind of working backwards here. So x plus 5 squared, if I multiply that out, I get x plus 5 times x plus 5, which is equal to x squared plus 5x plus 25. And again, combining these two like terms, notice in the middle they are the same, and that will happen every time, but I end up with x squared plus 10x plus 25. So can you see the relationship or the pattern between the value that's inside the parentheses with x and the values that I get when I multiply it out? So how does negative 3 relate to negative 6, and how does negative 3 relate to 9? Well, the negative 6 comes from doubling the value that's inside the parentheses. And the 9 comes from squaring that value. Right? So our goal is to go from here backwards. So if I had x squared plus 16x plus 64, how could I get back? Well, what number would I double that gives me 16, that when I square it, I get 64? And hopefully you did say 8. So this compacts back down into x plus 8 squared. And if we multiply that back out, just like we did the above two examples, we should get this x squared plus 16x plus 64. Quadratics that can condense back into this little squared form, we call this a perfect square trinomial. Trinomial because it has 3 terms, and perfect square because we can take it and scrunch it back up into a perfect square. So it's all about identifying that last value, the third value, to make this a perfect square. So let's say that we have x squared minus 8x. What value would I have to add in that would make this a perfect square trinomial? So you take half the middle value and square it. So negative 8, half of that is negative 4, and negative 4 squared gives me positive 16. This is the perfect square trinomial, and so now it can be condensed back into x minus 4 squared. So where'd the minus 4 come from? It's half the middle value, and we can check ourselves. Half of negative 8 is negative 4. Negative 4 squared should give me 16. See how they all work together? So if we're going to solve a quadratic by completing the square, it's going to be all about finding that third value, the c value, the piece that's going to make it the perfect square trinomial. So let's look at an example here. Let's say that we have some quadratic. Alright, so I have x squared minus 8x plus 5 equals 0. Notice that this is in that standard form. My exponents are in descending order, so x squared, x to the first, technically x to the 0 is equal to 0. So this is my standard form, and I'm going to solve this by completing the square. So we have to go back and think about the perfect square trinomial. Is 5 the c value, or the plain constant, that makes this a perfect square trinomial? Well, half of -8 is -4, and -4 squared is 16. So 5 is not the value, so I'm going to move it to the other side, in this case by subtracting. So I get x squared minus 8x. I'm going to leave a little space because there is a number. -5. Now we decided that c value should be 16, again because half this value is -4, so half of -8 is -4, and -4 squared is 16. So if I add 16 right here, this is now a perfect square trinomial. But this is an equation, so if I add 16 to the left, I have to add 16 to the right-hand side. Now the left is a perfect square trinomial, so we will condense it back into its squared form by just taking half the middle value. So half of -8 is -4, so x minus 4 squared equals, simplify the right-hand side, -5 plus 16 gives me 11. So there we completed the square. We can go ahead, our original goal was to solve this, so I'm going to go ahead and solve this. I need to bust x out of this squared piece, but I don't want it to be squared in the end, so multiplying it back out is not the option here. The way I'm going to get x out of these parentheses is by getting rid of the square. So the way we undo something that's squared is by taking the square root of both sides. So the square and square root cancel out. I get x minus 4 equals, whenever we take the square root with a variable, we have to account for the original being a positive or a negative. So we have plus or minus the square root of 11. Now I want to get x all by itself, so I'll just add 4 to both sides. I get x equals 4 plus or minus the square root of 11. It's not pretty, but that is the solution to this quadratic. Of course, completing the square is not the only option. To solve a quadratic, we could do quadratic formula or factoring if possible. So where does completing the square come in handy? Completing the square is used for, write it out, completing the square is handy in writing equations of circles. All right, so you couldn't see that. So completing the square is handy in writing equations of circles. So check out the next video and we will do just that.